So today we are going to have a look at a very special abstract data type called as the stack. Once I use the word abstract data type, I need not go into details because we have dealt with this the definition of abstract data types in a very detailed manner. So I hope you would be remembering that, and there is no point in describing that once again because that would be wastage of time. So let us briefly introduce this stack. So today we are going to learn about this AGT, right? So the point number one which you would remember, it's an ADT, that's an abstract data type, right? Then the second point which you would remember is, in fact learn, is that it is an ordered collection of items. Ordered collection of items, right? So stack is an ADT and a stack is an ordered collection of items, right? And this stack allows insertion of new items and also deletion of items, right? But these two things are allowed, but with a very strictly enforced mechanism. So leaving apart this technical jargon, in simple terms we can say a stack is a list. It is a list of items, right? It's a list of items, but it is a special kind of a list. It is a special list with a very strictly enforced mechanism. As you know, with a simple list, let us suppose, for example, suppose this is a list of items with us, right? This is a list of items, and with this list, suppose this is list, right? With this list, this is a simple list. I am not talking about the stack, I am talking about a simple list. This simple list would also allow insertions and deletions of items, but those insertions and deletions of items can be done in multiple ways. For example, you can insert a new item here. You can delete an item from this place. This is insert, and then you can delete an item from this place. You can insert a new item here. You can insert a new item here. You can delete an item from this place, and you can delete an item from this place. So we can say in case of a simple list like this one, these insertions and deletions can be done either at the beginning or at the end or at some intermediate position, right? Like I explained in this example. Then, but this stack, since we said stack is also a list of items, but it is a special list. It also allows insertions and deletions of items, but a stack allows insertions and deletions. Remember, only from one end. What does that mean? That means in case of a stack, you can delete and insert only from the same end. Okay, only from the same end. That is, if you insert from this end, you have to delete the item from this end only. And if you insert from this end, you have to delete an item from this end only, and intermediate option is not available, right? So same end, that is either beginning of the list or end of the list. Okay, so insertions and deletions. Insertions and deletions in case of a stack can be performed only either from the beginning or from the end, right? Either from the beginning or from the end. Okay, and the next thing you would remember is for example, imagine this. Imagine this. Let us suppose this is a list and you can only, suppose this is the beginning of the list, you can only add items or delete items only from this end. So for example, we add 1, then from the same end we can add 2, then from the same end we can add 3 and so on. And remember, in case of a stack we use a special name called as top of the stack. Top points to the topmost element of the list. For example, once we inserted 1, then top will point to 1. Then we inserted 2, now top will point to 2. Then 3, then top would point to 3 and so on. So in case of insertions, this top dynamically moves upwards, whereas versus in case of this, right, in case of deletions, suppose you can remove the first item you can remove is 3. So once you removed 3, you get 2 items, 2 and 1. Now top was earlier pointing to 3. Now since we have got that deleted, top will point to 2, and then once we get top, this deleted also removed, top will point to 1. Now in case of deletions, top dynamically moves downwards. So dynamically moves downwards. In case of this, dynamically moves upwards. Since a stack can grow in size or it can regress in size, so we can safely say that a stack is a dynamic, constantly changing data structure, right? Data structure. Now as regards the safest bet in case of the end, since I said that insertion deletions can be made either from the beginning or from the end of a list, but the safest bet is perform these operations from the beginning of the list, since the complexity would be more in case of you do these operations from the end of the list. Since this complexity, time complexity or space complexity, this is beyond the scope of your class, so you would stick to this, that the beginning end is the safest bet, right? As regards the operations, which can be performed on on a stack. Okay, you can insert, you can delete, and you can, these are the primitive operations, and then you can, primitive but most important operations, insert and delete, and then you can have one operation where you find or return the top element, return the top, right? But in technical parlance, this insert is known as push, right? Push operation. This delete is known as pop, right? And this returning the top is known as peep operation. Sorry, peek. This is peek, right? Peek. This is K, peek. Okay, peek operation. So I hope this must be very clear to you. So let us see these 3 operations in the next lecture. Thank you very much.